You have the next? Okay. Then my suggestion is we have three parts. First about knowledge management, why it's interesting, and especially in the era we are living today compared to generative AI. What's the difference? What is the added value of knowledge management compared to generative AI? Some definitions, origin and dimension, and main methods. About innovation, we will have an overview of various types of innovation and how we can use knowledge for sustainable innovation. And finally, the third part will be about technology and AI for knowledge management and innovation. And first of all, knowledge-based AI and a little bit about generative AI. At the end, I would like to have your feedback on this because the feedback is a part of knowledge management. We learn from feedback. It's okay for you all? Okay.
Yes, it's okay.
This is in case of you want to back to this topic. It's a MOOC I registered for engineering school in Paris, EPITA. Then you can use this also. First question is about do we still need knowledge management because we have generative AI? And this link we will not explore because I have no time, but you are free to explore this link later. We have a lot, and quite each day we have a new generative AI tool. Problem with generative AI that it explores the past data, and we want to explore knowledge, which is not exactly the same. Anyway, generative AI progress, and probably next year we will have the better tools, but for now we need still knowledge management. And this is to change, maybe move this. Okay. It is some phrase of statement of Chris Zelensky from University of Winchester. I have been working with him for several years. I met him in Washington 10 years ago. He is still involved in knowledge management. He says, using generative AI knowledge management raises the question of the responsibility gap. Who do you blame when things go wrong? In scientific communication, we have agreed that chatbot can't be authors because that imply a legal person. But who takes care of hallucinated references and other erroneous inventions? More broadly, are we at risk of replacing knowledge management with knowledge management? By the second knowledge, he mentioned knowledge discovery from database, from images, from text, from audio, etc., which is not the same as real knowledge. And some references, this is a seminal book on knowledge management written by my colleague Deborah Amidon, Innovation Strategy for the Knowledge Economy. And the second is my book I published in 2012. And it is 2 chapters devoted to knowledge management, describing rather practical approach to knowledge management. The first is more theoretical, but also applied, because she elaborated the assessment I will talk later about. And another reference can be KM World magazine. Then I put it here 3 references, but you can use this on a regular basis because it's interesting. Only with one remark, that it is more, of course, you have a lot of examples, but it is more tool-oriented because it is supported by the people, software vendors. Then the first reference is about 100 companies. They publish every year this list of 100 companies. If you are curious, you will check that there is more software-oriented than practical approach, but we have also practical approach. And some example of application in white papers with best practice, and you can maybe find something similar to your case in this. The knowledge management world was, I think it began also in the 90s. And it is a typical example of knowledge-based business because they got money with all this knowledge accumulated and spread it through this magazine and website. Now, this is some definition, as I said. What is the difference between data, information, knowledge, and wisdom? It is extremely important to understand that today knowledge is not really the knowledge because we derive or try to discover the knowledge from data and information. And first about data, it's at the base of this pyramid. It is everything we have around. It is codifiable, explicit, and we can easily transfer from one computer to another, from one system to another. Information is the upper level. It's contextual. It can be data with meaning. Then we can, when we see the data, if we have the knowledge to understand this data, it can become information. Then anyway, we are surrounded of information on the web, in the books, in the everywhere. And next we have knowledge. Knowledge is related to human. It is tacit. It can be information with context. We can have the information from the web, but with our background, we are able to understand and apply this in our situation. And what is very, very important here, that when we want to transfer knowledge from people to people, from people to computer, it is not so easy, because when you talk about something to someone, you have your own background and the person has also the background, and this person may interpret. When we transfer knowledge from people to computer, we have to use the models to do that. And it is also not trivial, because we have to select the right knowledge model for efficient system. And the last level is about wisdom, how to use the knowledge for decision taking, for judgment, etc. I hope it is clear for everybody what's the difference. And as generative AI use data, you see the difference. This is a break between these two levels, data, information, and knowledge and wisdom, because it's not the same implementation in computers as data and information, and knowledge requires different implementation. Okay, and this is, I can not see everything. Okay, it is just about way of thinking, because in knowledge management, we try to think knowledge, while in data and all related to generative AI, we think rather data. Then as example, I took this toy, which is a sort of a box with various pieces, various shapes, and various dimensions. And what we can do with that, When we use data approach, we just collect first, then we know that we have this. In data approach, we just put the same pieces into the boxes. And in knowledge approach, we have to understand what we can do with these boxes, with these pieces in the boxes. Then, for example, we can build a robot, we can build a car, but for this we need knowledge, we need the instruction, how to follow this to get the car or robot. You see that these two differences. In data approach, we collect first. It is what we call today machine learning. We collect data and then we use the algorithms. In knowledge approach, we have to understand first, and after we use this knowledge for various problem solving. And for example, this typical example of deep learning and collective experience. In deep learning, we collect data and then we use the algorithm to find something. In collective experience, we just collect, as you mentioned before, best practice. We collect the best practice and we use specific algorithms, as for example, case-based reasoning, to find something similar to what we are searching for. Okay, it is some example. If we have this on the screen, what is that? Data, information or knowledge. Of course, it is data. And for French people, it can be information because it's social security number. Then only French are able to understand this. Or Portuguese, other traveling to France, maybe, or studying in France. Another one is information. Juan was born on March 15 in Mexico City. It's in information. We don't know Juan, but we got this information. This one, it is a picture. It is data. If I add this, it is ingredients, that it is just information, what we need to prepare this drink. And this is the way of doing this drink. This is a know-how. This is knowledge. And another one is also data, except if you know wines, and especially from the south of France, you may know, interpret what's that. And this one is King Solomon giving the advice to the people coming. It's about wisdom. I hope it is clear in terms of definition. If not, you ask. This is the first definition, those of Bill Gates. Bill Gates prepared SharePoint portal. He was always in advance in marketing and communication. Then 2 years before SharePoint portal was issued, he wrote a book about business and the speed of thought. And in this book, he gives the definition: knowledge management is nothing more than managing information flow, getting the right information to the people who need it so that they can act on it quickly. And this is two things wrong in this definition, because he's talking not about knowledge, he's talking about information. And the next definition is those by Deborah Amidon that I just added tools. And this is an integrated system of initiatives, methods, and tools designed to create an optimal flow of knowledge within and throughout an extended enterprise or organization to ensure stakeholders' success. Then it is 3 ingredients in this definition. First of all, someone has to take initiative. It can be someone from middle management level or top management level. Then it is advised to use the methods and appropriate tools in aim to create an optimal flow of knowledge. What it means, optimal flow of knowledge? It means that we will collect knowledge for the people who will have to use this, and the people will use this knowledge. This is just a flow. We collect and we use. We cannot only collect and not use because it's useful, but it should be a flow. Within and throughout an extended organization, it means organization with partners, providers, etc., and clients. And everybody should be successful from this. If we have not this condition, it's not working, simply. Then now we will explore, before I will give you the definition of knowledge flow. For example, if you ask ChatGPT, you cannot find this definition because many articles and books are by Ikujiro Nonaka, who suggested rather theoretical knowledge flow, call it SECI, SECI. But this is practical. This knowledge flow is from practical point of view. And this is about creation, collection, processing, and sharing of information and knowledge in an organized and optimized way, taking into consideration the various activities of the extended organization, as well as needs and individual and collective motivation of all participants. Motivation is extremely important here, because if you are not motivated to share the knowledge, it cannot work. And in many cases, with a trend for knowledge management at the beginning, at the fail of the 90s, the people started to collect knowledge, to collect data. And after this, they said, okay, how I can use this data? It's impossible because, and the people stopped because they were not motivated to collect this. They was not able to see how the collected data can serve them to be more effective in their work. Then it should be effective. It should be only focused on on the specific activity. And a small picture, a small drawing from the corner of this definition is here. It is specific for the company, but you can replace this by university. For example, you are the teacher, then you have students, you have the other professor providing the classes, and you have you recorded the knowledge base with various exercise, with exams, etc., and how it will be exploited. It can be exploited by the other teacher to update your program in function what the student said, etc. This one is adapted to the company. Then we have design department, for example. The company has client, work with distributor, have a hotline, technical support for client and technician, going to the client to repair something. And they collect what we call the base of experience. You mentioned best practice, we can call it best practice. But in French, we say retour d'expérience, which is maybe we collect not only best, but also the bad practice, because we learn the most from error than from the best, maybe. And in the case of this company, it can be exploited to update decision tree and technical manuals to use for decision support system for hotline, client, distributors, use this knowledge for training program and improve the design, etc. Okay, and a little bit about the origin, because at the beginning it was rather management trend. I don't know if you know Peter Drucker. It's Peter Drucker who was initiator of this. He said we need to organize the company around of knowledge of all participants. And there is some people working on this. Peter Drucker, I mentioned Ikujiro Nonaka, also Charles Savage, digital company, and Deborah Amidon, Leif Edvinsson, and some other. We can say as for AI founding father and mother of knowledge management coming from management. Second, it was AI, because in AI we work at, since 1960, I think it was the first expert system on knowledge acquisition, knowledge modeling, knowledge processing, with various approaches, problem-solving approach, decision support system, machine learning. Today, when we talk about machine learning, people consider machine learning is about what was called before statistical learning. Machine learning was initiated, what we call symbolic machine learning, was initiated by the researchers at the Chicago University, by Richard Michalski, George Ross Quinlan, and some others I will mention maybe later. AI also brought a contribution to knowledge discovery in text, database, images, natural language processing, concern programming, multi-agent system, and now generative AI. And it is a huge contribution of AI in this, but from the beginning, the people from management didn't consider AI. It came at the beginning of the 90s. Marketing also, they were interested in business intelligence, e-commerce. However, e-commerce is still not very intelligent. We have still the traditional fragmentation. We have to go through the specific types. There is no AI in e-commerce today. I don't know why, but it is a way of thinking. Human resources, they were interested about how to motivate people by using their talent, how to organize a talent in the company. And intellectual capital, it was something, I don't know if Leif Edvinsson invented this, but anyway, he's considered as a father of intellectual capital. And now there is still New Club of Paris discussing this kind of thing about intellectual capital. It is simply about using the best of our talents, and especially in organization and company. This is just, I will go very quickly through that. You can find this in the first book, and you will have the slides, of course. This table was elaborated by Charles Savage in 1991 from management point of view. And what I highlighted yellow, it is the situation we have in the company today. Then in company, there are still hierarchical organization. It's a project-to-project basis. It's more information-based. while we have to be in 5th generation of knowledge as asset, with collaborative innovation system, with kaleidoscopic dynamics. It means when we change something, we cannot back to the previous situation, with exploration of intellectual capacity, symbiotic network between department. Self-managing knowledge workers. Again, it is Peter Drucker, but I call it knowledge cultivators rather, because worker is just exploring, doing what it is what they have to do, but cultivator has also the benefits from this. Cross-boundary learning and knowledge flow, then instead of just having project-to-project basis, we learn from a various exchange with international project, from clients, from the other stakeholders, etc., and from web, of course. And objective here is to, instead of having information-based technology, to have intelligent knowledge processors. And as in terms of customer, today the company work on customer satisfaction, and we are interested about customer success. We have to be successful because we use this approach. Okay, next, it is traditional technology with database, networks, groupware, intranet, data warehouse, ERP, and traditional information technology. And document management, because it's a lot of knowledge in document. Design in terms of concurrent engineering. And now we have AI by design and design thinking. You probably have heard about this method elaborated by Henry Chesbrook from Berkeley, which is nothing new, in fact, because we have to work with stakeholders. And economy, it is knowledge-based business, because we work with intangible, and it's related to innovation. Okay, I put this question, but I skip it for the moment. Today we have a multitude of heterogeneous sources, and we have to deal with that using this approach. And finally, knowledge management is as an elephant. Maybe you have heard about this fable. It's an Indian fable. It's a story of a prince who traveled on the back of the elephant, and he arrived into the village of the blind people, and blind people touched the various parts of the elephant, try to guess what is an elephant. And one said, those who touched the leg said, elephant is like a pillar. And the second said, no, you are wrong. The elephant is like a rope, etc. And they started to discuss, and the prince said, you are all right, because the elephant is something the whole. It's the same for knowledge management. You can have design department, marketing department, but all these people have to work together and have the common knowledge base to be effective. Okay, this is the first part. If you have the question, first part maybe it's a definition, and after, okay, I will go ahead with, before the question, I will go ahead with the methods, and we will have the question after, okay? And then today, we can use, and we need this kind of approaches, because we have disaster risk management, especially natural disaster, a lot of natural disaster. The second complex problem is sustainability and climate change. Also, we need to bring together the all possible knowledge about that. Corporate social responsibility, social and societal innovation, knowledge economy, product service economy, circular economy, or probably have heard about circular economy, circular energy, and innovation management. And we have a lot of needs to introduce knowledge management, and it will really help. And waste management, for example, because technology and many other fields generate a lot of waste, and we have to manage this. In practice, we can have tool-oriented, which is rather pushed by software vendors. I will go very quickly through that. Second is users activity-oriented. This one is really very important, very interesting for everybody, because usually we need help for given activity. Then what we can do at this stage is, for example, help desk, diagnosis, decision support system, knowledge capitalization, best practice in given field, content management, design and eco-design, skills and competency management, business intelligence, e-learning, and other form of learning, because today we have to be, as teacher, we have to be very inventive. Another, it's management oriented. Think about the previous users activity oriented, because it's really very practical. And management oriented is rather good when you have access to top management in the company or university or other context. It can be related to innovation process management, because today in many companies, even at the university, innovation is not really managed. Sustainability with all components, as for example, very known 17 goals of United Nations, corporate social responsibility, climate change, leadership management, well-being, which is also the trend. And in terms of method, the first, it is user-oriented. Then we have several possibilities to start the process. And first of all, it can be a demand of someone. It can be real need. We have to help someone in the company, the population of people or several departments. We have a problem to solve. Or it can be an opportunity to progress with that. The first thing we do is we have to understand first of all the knowledge. What is the knowledge related to one of these four things? What skills we need to do that? And experience. Then we can use the related knowledge models, select the related tools, the best tools that apply, add maybe new technology, involve the user at this stage. And sometimes the user don't know about the latest technology, or afraid the technology. For example, today the people are afraid of AI in many situations. And then we select the tools, we prototype, and we can extend this application to the other possibilities as training or design, or depends on the situation. Then this is bottom up, and the second is top down. And when we have the access to top level, the first thing we do is the assessment. Where we are today, and what progress we have to do. And this is assessment. I just will give you an example of this. Of course, it should be adapted in each situation. From this assessment, an assessment is, this is the 11 modules, and what we work on. On this axis, we have, for example, collaborative process. Collaborative process means if it's someone in the organization or company in charge of facilitating the process, because we need someone managing this. Performance measure, if the measure in terms of tangible and intangible are measured. Education and development, it's about training. Learning network is rather with learning with outside. Market positioning, it's for companies, but also for university, because we have a top 100 of university now, and it is sort of a race for the best university. Product and services, in terms of the university, that can be new courses. Market penetration is about how large is the market. Market image is about how we are perceiving from the outside. Leadership position, environmental impact, and how technology is used. Then how it works. We put the people around the table. It's around 2 hours, but with the preparation before. And inside, it's a current situation, and outside, it's a desired situation. And from this, we can elaborate the project to achieve the goals. It should be still managed. This assessment could be made each year, for example, depends on the company. Okay, and finally, recipe, sort of recipe that apply to knowledge management. The first of all, we have to understand, know the context, because context can influence the way we will do. Next question is about what we have to do, why we have to do, who will participate, who will need this knowledge we put together. Nature of knowledge, it means how the currently people in the organization exchange the knowledge. If they write, if they describe the experience, if it's in the scientific papers, etc. And we have to think about how this knowledge is shared to select the right model. And then select the tools. Usually it's hybrid, connecting several tools. And we have to do small and think global, for build the first application, and then think how to extend this to the other activity at the university, company, etc. And sometimes we can need at this level, we can need to go top and make the assessment. Depends on the situation. Okay, then finally, think about the principle, which is initiative, methods, how we will organize the knowledge collection and using, and implementation with the tools, and measurement of benefits. And principle is that a computer or internet or available technology should be intelligent assistant of human, not replacing human. Okay, I stop this. We have the whole image of knowledge management. Innovation. Why we do this? To innovate. Maybe one just point, but we will back to this. Influence of AI on knowledge management, as I said, is a way of thinking, because usually we solve the problems. What approach? Depends on the situation. What is extremely important is the human-machine interface, because the application as well as knowledge collection and sharing and related application should be intuitive and not with documentation in terms of, I don't know, 7 volumes of documentation as we have for some softwares, okay? It should be intuitive. What technology depends on the situation again. We can use data, machine learning, deep learning, or generative AI or chatbot to ask for something, but chatbot should be effective. Because if you ask a question and you got a stupid answer, you never will use, this chatbot. And in terms of knowledge modeling and processing, I will explain a little bit later. Innovation, okay? Then it is, you have the innovation machine here. Then usually start by ideas. Then it can be someone may have the ideas, or it can be generator of ideas, automatic generator of ideas. Anyway, these ideas are evaluated by 3 persons. Why 3 persons? Because someone is in charge of technological feasibility. Second person can be in charge of marketing, if we have a market for that, and if we have a skills for that. Then we need at least these 3 persons to evaluate the ideas. Then idea can be selected good. In this case, it go for implementation, produce the revenue or benefits, and we fuel the machine for innovating. This is something missing in this drawing compared to what we are talking about. First of all, the needs. The innovation should address the needs of the person we want to sell or address, provide something to this person. And the second, we can invent new needs. In the case we address new needs, it is usually incremental innovation. If we invent new needs as iPhone, smartphone, it is disruptive innovation or radical innovation. Next, we need the knowledge about market, about technology, about the competitors to succeed. And we need technology in terms of knowledge flow, virtual networks, ICT with double meaning, with information and communication technology, but also imaginative and creative technology, with intelligent autonomous system, etc. And we will have to take care about environment. It should be rather green and not polluting, if we can do that. And we have to try. This is my definition from idea to sustainable success of all participants, but we will see the other. This is a sort of mapping about the various types of innovation. Then, as I mentioned, we have incremental and disruptive or radical. In terms of purpose, it should be innovation in product, in service, in process. In terms of organization, it should be closet. The first drawing I shown, it was closet innovation because it's only research and development department who can innovate. Participative innovation is a whole company may participate, but it is inside of the company. Open innovation, it's open to the partners. Global innovation is for example, your project, because you are the people from various countries and working on a common topic, and this is, we can call it global. Responsible innovation and eco-innovation. Eco-innovation means we take care about, I described this in my book, I shown the cover. E as electronic and educative and collaboration, innovation, etc. Then you can interpret this. It's not only about green innovation, but also about collaboration and using knowledge. In terms of field, it can be technological. It is very popular. Social innovation. We work for social progress, including people, for inclusive innovation. In terms of economic, we change economic model. Cognitive innovation, we use the various cognitive model. Organizational, as knowledge management is a term of how we organize to be more effective. Managerial is about managerial method. Cultural is about changing of culture. With people traveling around the world, we may take the best from the given cultures. Green innovation is about greening, as you know, making things responsible, customer-centered, political innovation, innovation marketing, and the last is societal innovation, is inventing a new society. Then you have a big picture of all kind of innovation, and we can use what we want in this mapping to innovate. This is some example of incremental and disruptive. For example, Eiffel Tower it was disruptive innovation because it was never before, and the people didn't want to have this in Paris. And now it is a monument generating the highest revenue in the world from this. This is yogurt now existing now because they never asked the people if they want to buy this or not, and they spend the money on inventing beauty cream inside of the yogurt, but the taste was awful and nobody bought this. And this is a watch. This is, we can say, in the same time incremental and disruptive because we have already a watch, but it is computer in the watch. It is the same for surgical surgery robots. Now it's we can say it's rather disruptive because we are using this, and in some cases it's better than doctor, but doctor is still here, and it is good. And this is we station to play. And disruptive because instead of just playing with the finger, we play with the body. And it's disruptive innovation. Okay, then innovation can focus on research and development, on technology, on collaborative innovation, can be eco-innovation. And now there is a trend to focus on biomimetics. I just expertise at the made expertise of Horizon 2020 on 3D printers, bioprinters, and this requirement to use bioprinter, for example. Then the people invented ink to print things using waste from agriculture, things like that. Then we can be inspired. For example, what is the butterfly wings can inspire the future battery for preserving the energy, etc. And there is a lot of inspiration in nature. And all innovation needs knowledge to succeed. We need, even in biomimetics, we need to know, we need to observe the nature and know how it works, how to implement this. It is an old definition because it was elaborated by Joseph Schumpeter at the beginning of industrial era, 1911. It is still good. Innovation meets 5 main criteria. The manufacture of a new good, still good. Introduction of new production method or a new means of transportation, still good. Now we have solar transportation, solar planes, solar ship, implementation of a new organization. You wanted to say something, no, someone? No? Okay. Opening a new market and the conquest of new source of raw material. I think in terms of our planet, we already explored everything. Now the people are searching on North Pole and on the moon, in the meteorites. We will see. And another definition is again this of by Debramidon. It is why it is interesting because it's holistic perspective. Then it is about creation, evolution, exchange, and application of new ideas on 3 levels. Ideas into marketable goods and service for the success of an enterprise, micro level, vitality of nation's economy, meso level, and advancement of society, meta level. And it is described in the book for children and leadership executives in search of innovation. If you are curious, it's on Innovation website. Okay, and again, back to this innovation process, we will study in more details. And as I said, we have client partners and stakeholders that they can have ideas, and we will address the needs or invent new needs. The idea will be validated. But before going to implementation, we have the constraint to verify. If we have competitors, if we have skills and competency to do that, if it's technically feasible, what is the market impact? What is environmental impact? It should be ethical. And of course, we expect a return on investment at this stage and other benefits. And after verifying of all these constraints, we can go to implementation and then run the process as previously with continuous feedback, which is something mandatory for knowledge management. And during this feedback, we can have new ideas and improve or invent new things. And again, I forgot this. And okay. It is my definition. What is important here is in innovation, we have 2 steps. First is creativity, and second is transformation or implementation. In terms of creativity, of course, we want a sustainable success. In terms of creativity, it is, we will not watch this, but you can watch. The first is a video by Tony Buzan, who invented mind map. And he says in this video, everybody can be creative. There is the condition for this is to use the best part of the brain, not only left brain, but also right brain, right part of the brain to be more creative. And also alternative thinking. If you have an object, you have to think what are the various possibilities to use this object. And also he mentioned the speed of thinking, how fast you can create ideas. But conclusion is everybody is creative, but we have to work a little bit on it. And the second video is about, it's a TED talk about an artist who used generative AI for enhancing his creativity. In terms of creativity methods, I think you know, brainstorming, everybody knows this. Innovation Cafe, it's what I wanted to do with you. If it will be in life. Put the people around the table and think, work on various topics. And the participants have to elaborate the solution on a given topic. Another method is trees. I don't know if you have heard about this. It was elaborated by a Russian specialist of patents, and when he went, he was in Gulag during 7 years. He studied the patents, and from these patents he extracted only 40 inventive principles. And when after the collapse of Soviet Union, he moved to the United States and he founded a company called Invention Machine. But the principles are still very interesting if you are in deadline. For example, you work in the given field and you explored all the solutions from this field and you think there's no possibility to improve. Then you can refer to another field to find a solution. And it is a short video about explaining how it works to children at school. You can also see this is 3 minutes, something like that. Six Hat of Edward de Bono you probably have heard because it's rather popular. It is about wearing the hats of different colors. And if you wear a hat of red hat or blue hat, or you have to think related to the color of the hat, which is not easy, but it is very funny to do in teams. And if you have a real meeting, I'd advise to play with that because it's very funny. And my difficulty is to change the way of thinking, to change mental scheme from one to the other, to think according to the color of the hat. Okay, and co-creation, it's about innovation with client, described in the again by Deborah Amidon in terms of information technology. It was implemented in extreme programming, how to involve the client to the programming process. And design thinking is also about innovating with client. And condition for success is involving the user, because if you develop something for the user will think it's the user's baby, because he or she participated in the elaboration of this. This is condition of acceptation. Okay, and finally, innovation ecosystem. Then, for example, we have the researcher working on the given topics, and usually a researcher push the result to the company. And the other side is not very strong. Sometimes company offer the grant for students for PhD to work on specific topics, but it is not very strong. And in the company also work on innovation, and we have startups, and relation between a startup and companies is the startup try to push something to the company, and the company said you are too small. And in many cases it's not working, sometimes it's working, but the feedback here is not very strong. In terms of, I have the problem to solve, I will submit this problem to the startup to solve the problem for me. Education and training is something extremely important, because we can learn how to innovate and how to get the benefits. This is an example of school in Helsinki. We visited with the delegation of French Ministry of Education several years ago. and the children are working collectively on solving given problems. Policies, innovation policies, usually they push the innovation policies into this, into schools, into companies, into researchers, but there is no way to send the feedback to them, which is, and in terms of investors, the investors, we need, the research need money, and the startup need money, and that we need investors, and of course it is supported by technology and has an impact on environment. And another presentation of the same, but it is flat, it is this way. Now about technology. What kind of technology? As I said, innovative and creative technology, including AI, we need for successful knowledge management and innovation. First of all, technology has to support the whole knowledge innovation process in terms of smart and green. It should be smart and green, because today we have a lot of data. Everybody collects data. We have a lot of video and many similar things, and nobody clean this data. That's why we need powerful machines. We are looking for quantum machines or other things, because we have a lot of data and not relevant enough. Second point is it should be technology should help organizing and optimizing the sources of knowledge. That's why we need a collaborative space. The best solution is having in the companies, in the university, collaborative space for all participants. Instead of having things a little bit in Google Doc, a little bit in this, little bit in this, because we lose time searching. And more we have technology, less we have time, which is paradox. Then it should be organized, and we need a collaborative space, private collaborative space in organization, in project, in the companies. Facilitate the knowledge creation, discovery, learning, and training. Today we have a various way of learning, and maybe something is missing, that for example, if you learn from the web, the system of consistency is missing. There is not a system verifying things for you. You have to think, to use your critical thinking to know if it's something true or not. And we can do it with AI. It was done for expert system, and not yet now for generative AI, how to verify the consistency of the answers. Help sharing and finding. And finding, I mean relevant finding. I'm searching for something. With one click, I have to find the right answer. Because when you, for example, if you use Google, you have related to Google business model, you have 30 various answers at the beginning, and you have to select. Instead of this, I want the right answer to my question. It's also related to chatbot. Help building collective knowledge and experience. It is not about data, it's knowledge and experience. Decision support and decision making. Capitalization, how we can capitalize knowledge. For example, today there is a strong movement on capitalizing the community's knowledge, especially Aboriginal community. When I was in Hawaii, it's a Higgs conference, I also met the people, the team I worked online with them, Kohala Center for Development. And they said, okay, the American people come here to say us what we have to do, but we know what to do because this is as ancestral knowledge. Then it is volcanic earth, and we know what to do, but they're not interested about. And it is about transmitting this knowledge from maybe older person to children through information system and help innovating effectively. Then we have all of this that technology may help in this activity. And in practice, the knowledge, the life cycle is then we start with acquisition or discovery of knowledge. In some cases, we need to model the knowledge, use knowledge base and experience, collect the knowledge, building the knowledge base and experience, to process using various algorithms, various methods, and or just navigation for decision making. And from these 2 points, we can innovate. Then AI for sustainable innovation, we already said. Then AI can support the innovation process in terms of creativity, transformation, managing of sustainable success, may enhance creativity. For example, we can build using case-based reasoning system, we can build a generator of ideas. It is something very simple. We have application and people can introduce a new ideas, and this idea will go for evaluation. And then, for example, if you introduce new idea, the system may say, okay, but it's your colleague, Carlos, who had a similar idea. You have to connect with him to work together on this idea, for example. Help exploring idea, okay. Help verifying constraint. At this stage, we need simulators. In many cases, we need simulators. Evaluate impacts, knowledge. We are used to use KPI, but it is about KSI, key success indicators. It's not about performance, it's about success. Organizing and optimizing the related knowledge. And twin transformation, you probably have heard about twin transformation because it's a current trend at the European Union level also. Green and digital. Then we have to combine the both. In terms of, I just put this small mapping. Knowledge creation, we can create knowledge from experience, from learning, by learning, MOOC with a tutor, by discovering from data, image, etc., but also by serendipity. And many things come today by serendipity. We have heard about something and it's an opportunity for us to explore. Difference between decision making and decision support. A decision making is database. It's about classification, clustering, prediction, forecasting. And knowledge-based, we will use the expert system, case-based reasoning, constraint programming, multi-agent systems, and build the complex system. And for example, in autonomous vehicle, we will use database because from sensors, from the car, autonomous vehicle takes a decision. And this is an example of cockpit of new Airbus. And they decided, this last news, they decided to remove all AI before it will be sure. There is no AI in the cockpit of the new Airbus. Okay, expert system. And a principle is rather simple. We collect the knowledge from the expert, implement this knowledge in terms of object and rules to build the knowledge base. And this is the user. The user will use the inference engine, ask the first question. Then when he or she asks the first question, inference engine use the rules for reasoning and the object to object in the rules. Example of rule. Then rule, it's a reasoning that translates the know-how. For example, this is just an example of real estate, a system. If the client is rich and if the client has children, then choose a house close to school, else choose something else. Rules today, we are still using rules, and we can use also rules to clean database, to select things in database only relevant record from database, but in expert system, it's a reasoning related to the given problem solving. As in this example is to finding the house for someone who is looking for the house. Usually in expert system, we have a complex reasoning with a chaining of several rules to get the reasoning. Today, expert systems are embedded in the application. For example, if you ask for insurance, they use the expert system, then you have to answer the question. And when you answer the question, they say, okay, we can give you this or not. The same for, I don't know how it works in Portugal, in the other country, but in France, for example, if you want to get the money from assistance, the poor people may ask things, some revenue, and they have to answer the question. And there is still some fields we have embedded expert system in the applications. Another way of reasoning is case-based reasoning. We don't need the knowledge base in terms of object and rules, but we just use the cases. A case, it can be one experience, as you mentioned, Clara, best practice. Best practice in my experience. Then I collect in my, okay. I build a library of case, and we have analogy engine. And analogy, when you have a problem to solve, you ask the problem, and the analogy engine choose for you the similar case or exactly the same case you are looking for to be solved. If it's similar case, you have to decide if it's a right answer or not. If you decide it's a right answer, automatically your library of case is incremented, and we can say that machine learned a new case. It should be validated by the user. What more? It's very easy. It's our way of thinking. We still refer to the cases we solved before. And this is just connecting together the brains, the experience of groups of people. And how we describe the cases. For example, the case one, we describe the problem by parameters. Here we can use natural language, we can use vectors, numbers, etc. And we describe the solution. Second case is this, etc. And we can use this case base for searching the similar solution. What is interesting in this, that it is easy to use. It's quite natural. And we can also clip analogy engine on existing database. But before, you have to clean as usual to select right cases to avoid to have twice or 3 times the same. How it works? Then we have 3 algorithms. Analogy engine can use induction algorithm elaborated by Ross Quinlan in the 70s, described in the book Machine Learning Volume 1. Then only thing you have to do is to select the attributes with the highest information gain. And then you push the button and the decision tree is generated automatically for you. And you can, if you wish, if expert wish to improve, can play with weight and similarity at this stage to reorient the generated tree. Another one algorithm is the nearest neighbors. You probably have heard about nearest neighbors in deep learning. It's not the same because here it is analogy engine compare each record one by one, parameter by parameter to find the similar solution. And dynamic induction is the combination of 2 algorithms. And this is quite easy, quite natural. And we have many applications for this because it can be generator of ideas. We can use it for best practice, for diagnosis, use for platform for matching of offer and demand in many, many cases, for games design. The condition here is to have analogy. If you don't have analogy, don't use it because you cannot find the similar. It is very effective with few data. I mean, this is green compared to deep learning and other and generative AI because it can be effective with only few data. We don't need to train the model. We can use directly on the case base. This is an interesting video, but it is 17 minutes. Then again, if you want to watch the video by John Landbury from DARPA, he talked about 3 generations of AI. But in fact, he forgot the first generation neural networks. Then what is important is these 4 points. How the system AI was good and is good in terms of perceiving things, learning, abstracting, and reasoning. For example, today, generative AI, there is no reasoning. Then the people are working on improving of reasoning. And also, a nice example of he gives in this today. If you use generative AI and you are searching, you have a picture of cat, and generative AI said it is a cat, and you ask how you know it's a cat, and generative AI has no answer, and the people have an answer because it, for example, how people learn. You need 3 or 4 images of cat, and you say the cat is, you can describe the cat. It is animal with 4, having 4 legs, queue, etc. And this is much more easier and greener than generative AI. Depends on the situation, depends again what you need. And finally, we have all of this in AI that people invented since 1940, because the first neural networks were built in 1940. And then we have again the various reasoning methods in terms of case-based reasoning. I talk about inductive reasoning, qualitative reasoning, analogy-based, model-based, spatial and temporal reasoning, probabilistic and uncertain. In terms of machine learning, at the beginning it was artificial neural network. Now we have deep learning and generative AI. And we can zoom on this here. Inductive and deductive machine learning, data, text, and image mining, voice mining, multi-strategy machine learning. It was an idea of founding father of machine learning, Richard Michalski, when he moved to Fairfax near Washington University. He invented this multi-strategy machine learning. It is a sort of toolbox. Then you have a various algorithm in this, and in function of the situation, you can select the algorithms that apply to the given situation. Genetic and evolutionary algorithms. In terms of technology, we have constant programming. In 2 minutes, I will talk about this. Logic programming, architecture of AI system, multimodal and intelligent interface, multi-agent system. Ask Zaya because she is expert of multi-agent systems. Today it's a trend. We have the platform methodology, architecture, and in terms of behaviors, cognitive and reactive agent. And the trend today is to have all algorithms of deep learning available in multi-agent system. That probably will replace existing system. I'm very confident in that we can have this multi-agent system and on the other side ontology and combine these both. Application and experience a lot because there is a lot of books, a lot of application made with AI. In terms of knowledge, we have acquisition method, model, conceptual model ontology, which is very hot today. Knowledge representation, management, discovery, engineering. In terms of processing, today we talk a lot about natural language processing, natural language understanding. It is strong link with this branch here, LLM and RAG models, speech recognition, image recognition, virtual reality, signal processing, knowledge processing, and semantic web. And in terms of hardware, we back to neural machine now because they tried the various type of machine. And hardware, we have robots, humanoid robots, smart IoTs, drones, and everything working today that we can use. Keep this in mind, except we have to zoom this and maybe develop this branch more, but you have all techniques represented on this drawing. In terms of AI family, we have traditional IT, symbolic AI, knowledge-based, and generative AI. And now new trends in neurosymbolic AI, we combine neural and symbolic AI. And overview of knowledge method, I skip this because it's just image summarizing what kind of model we can use in AI. This is ontology, example of ontology. Then today we use ontology. Why? Because ontology can express concept and relation between concepts. Then with Zaya, we had a PhD student working on frauds, various frauds. Then we discover every day around 10 new methods of frauds coming. Then if we use only generative AI, we build the model, deep learning, saying deep learning. Building the model for deep learning, it is not possible to update this. That's why we connected ontology with deep learning for solving this problem. It is just concept and relation between concept expressed in various for various situations, and you can find on the web various models of ontology to reuse. It is not necessary to do it from scratch. If you need to do that, it is the best tool, still Stanford and Protégé ontology editor. Constant programming. Again, I talk about this because it's made in Europe, and Americans don't have this, and they are using deep learning, which is very polluting, instead of using such a simple things. Then when we have the combinatory problem with constraint, we use constraint propagation engine. And we have the possibilities, and by using constraint propagation engine, we reduce the search of solution and find solution. Example is 8 Queen. You have first the video explaining this by Pierre Schaus, one of the inventor of this, and it is also his MOOC available on this. And if you want to play, it's a software I recommend. Is easy of Optaplanner. It is very important when you address a combinatory problem with constraints, such as scheduling, timetable, resource allocation, route optimization, logistic planning. It is much more efficient than using generative AI for that. We just need to define the constraint, and we use a constraint propagation engine to get the solution. Very quickly, machine learning, just to give you a historical sketch. VNRNHEP 9040, Queenan 76, genetic algorithm 80, STAR, another algorithm 81, multi-strategy machine learning 2000, and knowledge discovery technique from 81. It's not new. Machine learning is not new. This is a picture of industry. I don't know if you are interested. If you are interested, you can back to this picture. This is a trend, and maybe some things, because we mentioned the first generation. You can use knowledge model to collect just relevant data. And another one is if you have still multi-source heterogeneous unstructured data, we can use, on one hand, data-driven machine learning and integrate this with human knowledge and models, inject ethics to obtain explainable, robust, and strong AI and for the application, okay? And finally, what future? It's neuromorphic computer com and augmented human and so on. Then I finish on this, and now we can have a discussion, ask questions, and